You can probably tell this video is a little bit different. This time for our lesson, I thought I would demonstrate for you here on the screen, and hopefully you can see me and hear me okay. We're going to go ahead and take a look at lesson 3A.2, and we're talking about angle relationships in triangles. Last lesson we talked about classifying triangles. Today we're looking at certain angle relationships that are always true in triangles. So as we look at this, the first thing we want to look at is the sum of the interior angles. Now remember that the word sum means addition. We are adding the angles together. And you probably already know this, but the sum of the measures of all three angles of any triangle will always have to be 180 degrees. Okay? All of these angles are going to add up to 180. And what we can do is we can use that fact to, if we are given two angles, to find the third angle, we can set up an equation equal to 180. And so it'll be angle plus angle plus angle equals 180. And as we move forward, the other thing I need you to know is the exterior angle theorem. And that is that an exterior angle, I'll explain what that is here in a second, is always going to be equal to the sum of what we call the remote interior angles related to it. So an exterior angle is formed by extending one of the sides. So in this case, when I extend this side, I create this exterior angle 1. Okay? And that angle measure has to be equal to the sum of these two angle measures, angles 2 and 3. Right. And so an exterior angle is always equal to the sum of the two non-adjacent interior angles, which we call remote interior angles. So in this case, the measure of angle 1 is equal to the measure of angle 2 plus the measure of angle 3. And if we're given two interior angles and one exterior, then we can always make an equation by adding the two interiors and setting them equal to the exterior. And there's a couple other ideas that are going to be really crucial for this lesson. One of them deals with isosceles triangles. So there's not a lot to write down, so just kind of follow along as we're reading this. So in an isosceles triangle, the two congruent sides are called legs. So in this triangle, AB and CB are the legs. They're the congruent sides of an isosceles triangle. The sides intersect at a point called the vertex angle. So in an isosceles triangle, the two congruent sides always intersect at what we call the vertex angle. The side that is opposite from that vertex angle is called the base. Okay, so AC is the base because B is my vertex angle. And then the two congruent angles, here and here, along that base, are called base angles. Okay, so one angle is always called the vertex angle. The angle formed by the legs is called the vertex angle. The other two angles have to be the base angles, and they are always congruent to each other. Okay? And so if I only give you one of these angle measures, we know the other one is equal to that. To write an equation, consider what parts are going to be congruent then. And then also in an equilateral triangle, it's also equiangular, and the three congruent legs, or sides, are called legs sometimes, but there are three angles and they are all congruent. And because they are all congruent, and we learned a second ago that all three angles add up to 180 degrees, they're all equal to an equal portion of that 180. So if I just called each one of these x, x plus x plus x is 3x. So since that equals 180, and if I divide both sides by 3, I know each angle would have to be 60 degrees. Okay, so in an equilateral triangle, we need to remember that all three angles are 60 degrees. Ignore the bell. So what we're going to do is we're going to go through and we are going to practice some problems, and in each one of these we're going to write an equation for the situation using the information given and solve that equation for x. So number 1 here, we're given a triangle. These are all interior angles. There's no exterior angles given. So we're just going to say that angle plus angle plus angle equals 180. That's how we're going to set up our equation. We're just going to fill in the values they give me. So this first angle, 15 plus 7x plus the other angle, 55, plus the third angle, 40, must equal 180. Move this over a little bit. So there we go. Now all we have to do is start by combining like terms. That's always our first step. Before you try and move anything across the equal sign, combine your like terms to make your equation as simple as possible. So we've got 7x, but then these other like terms combine to equal 110. Okay, kind of done the math ahead of time, but you can use your calculator. 15 plus 55 plus 40 is 110. That is still set equal to 180. Then we subtract 110 from both sides, and when I do that, we're left with 7x equals 70. And then if you divide both sides by 7 now, x is 10. And that is the answer they wanted me to find, and so I don't have to plug in or go any further because all I had to do was solve for x. Okay? If I go too fast and you need to pause the video at any time, make sure you hit that pause button. Otherwise, we're going to keep moving right along. In this example, though, we've got two interior angles, D and E, but this is an exterior angle at F. Okay? And remember, we have that exterior angle theorem right here. The measure of angle 1 equals the measure of angle 2 plus the measure of angle 3, or the measure of the exterior angle is always equal to the sum of the two interior angles. So as we look at this, our exterior angle here must equal the sum of these two interior angles. So that's how I set up my equation. I say that my exterior angle, 8x plus 2, has to equal 44 plus 2x plus 6. And then we go about solving that. Again, combine like terms first. Simplify that right-hand side. Everything else just drops down. 44 plus 6 is 50, so that becomes 2x plus 50. Now, usually what we're going to do is get rid of the smaller x term on one side first, so that we only have x on one side of the equation. So if I did minus 2x here, I'll write that step in. That gives me 6x plus 2 equals 50. And now we can subtract 2 from both sides. So 6x is 48. Then divide by 6 on both sides. And we get x is 8. Now at any point, if you want to know if this is a right answer, or if you wanted to check your work, you can always plug back in and see what we get. If I plugged in 8 here, 2 times 8 is 16. 16 plus 6 would be 22 degrees. So when I add 44 and 22, I get 66 degrees. According to my equation originally set up, this should also equal 66. Well, we can plug back in and check. When I do 8 times 8 and add 2, 8 times 8 is 64. 64 plus 2 is 66 degrees. Okay? So those aren't part of my answer, but that's how I can check my answer. Again, ignore the bell. So as we move forward on into the next page of our notes, we're going to keep doing kind of the same thing. What I'll probably do here at some times is I'm going to have you pause the video and try some of these problems on your own, but I'm going to help you get this one set up first, because this looks a little bit different. On number 3 here, we are given this kind of a picture. Don't be confused, or don't be maybe misdirected by extra information that isn't really needed. They've drawn an exterior angle here. However, the important part is really that this is an isosceles triangle. Okay, we have an isosceles triangle where the legs have these congruent angle markings, which would make this 96 degrees, your vertex angle. And then this angle 2 is a base angle. Well, the other angle that is a base angle is over here. And remember that the base angles are congruent. So it looks like there's not enough information here, but there really is. These two angles have to be congruent. So if the measure of angle 2 is x plus 53, then this other angle measure is also x plus 53. Okay? So when I go to set up my equation, again, I'm just using the fact that I've got all 3 angles of a triangle that add up to 180 degrees. So the measure of angle 2 plus this other unknown angle measure plus 96 has to equal 180. Well, like I said, this other unknown angle measure is really the same as the measure of angle 2. So it's like I have x plus 53 here, plus another x plus 53, plus that 96 equals 180. Okay? And so I'm going to just start combining like terms, but also you could think of it as 2 times this x plus 53, since there are 2 of those angles. Either equation we start with is going to still give me the next equation. When I have 2 x's, that's 2x, and then 53 plus 53 is 106. So whether I combine my terms here or I distribute here, I get this as the next line. But then you also have your plus 96. Okay? And now we want to combine these like terms still, or you might have done those all together up at the top, and so your equation would look like this. And then we can start to solve for x. So the first thing we want to do is subtract that 202 from both sides. And that gives us 2x equals negative, hold on, check my calculator, 22, that's what I'm double checking on. And then we divide by 2, and you do get a negative x value, and that's okay. X is negative 11. That does not mean we did anything wrong. If I plug that back in and I get a negative angle measure, then I've done something wrong, because we can't have negative angle measures, but we can get negative values for a variable. And so if I did plug that back in, negative 11 plus 53 is 42. So both of these angles would be 42 degrees. And if I add all 3 of those up, 42, 42, and 96, that adds up to 180. So I know I did that right. All right, so for this next one, we're going to set this up in a very similar fashion. I'm going to start by writing your equation, then I want you to pause the video and try and solve the equation on your own and check it, and then you can continue watching to check your answer. But we do have another isosceles triangle. Again, don't be confused by the extra lines that are drawn in. Really, this is what we're focusing on. This isosceles triangle, in which the base angles are congruent. I know these are both the base angles because they're along that base, that third side that's not congruent to the other 2. So when it says the measure of angle 2 is x plus 130, this is actually the vertex angle. All right. So again, I'm going to add all 3 angles to equal 180, but then this other angle would also be 31 degrees. So this is the equation we should have. Okay. All 3 angles should add up to 180. I want you to pause the video and try and solve that equation on your own. If you need more time, keep the video paused here. Otherwise, this is the answer we should get. X equals negative 12. All right? So as we continue to move forward, in the next few problems, you'll notice the directions change a little bit. Now, instead of just finding x, we're going to plug back in to find an actual angle measure. So again, we're going to start off with looking at which of those 2 basic facts are we using. Are we using the fact that all 3 interior angles add up to 180? Or are we using our exterior angle theorem, that the exterior angle is equal to these 2 other angles added up? And that's what we're doing on number 5. So before we can think about finding the measure of angle UEF, we need to find the value of x. And so once again, we're going to set up an equation where this exterior angle, 16x, has to be equal to the sum of these 2 angles. So your equation would look like this. 16x equals 65 plus 6x plus 5. Okay? And as we work through that, we want to combine like terms here. So 16x equals 6x plus 70. 65 plus 5 is 70. Then we could subtract the 6x from both sides, giving us 10x equals 70. Divide both sides by 10, and x is 7. Now, since x is 7, I want to find the measure of angle UEF. So we write measure of angle UEF equals, and I substitute in for this x. This is UEF. That's our exterior angle. So all I'm doing is 16 times 7. And when I do 16 times 7, that ends up equaling 112 degrees. And again, we could plug that in, or we could plug in 7 for this one, and add those together, it should equal 112 as well. That's how you check your work. Okay? Number 6, very similar problem. We have our exterior angle here equal to the two remote interior angles when added together. We want to find the measured angle F this time. So again, we're going to find X, plug it back in to find that. What I want you to do is pause the video here, try and set up your equation and get to this final answer all on your own, and then click play to check your work. All right, this is what we should have gotten. Should have gotten the measure of angle F is 56 degrees. All right, let's keep moving forward and finish these up. You're going to get some problems like this on your assignment and quizzes and tests where you have to find the missing angle measures. You need to think of this as a puzzle. You want to find the missing pieces to the puzzle. Well, we've got two triangular shapes. We know these three angles should add up to 180, just like these three angles should add up to 180. There's not really any exterior angles we can use in this one. So we are trying to find this angle measure down here. In order to find this angle measure, I need to know these other two so I can subtract them from 180. I don't know this angle. I know that it's part of a 90-degree angle, but I don't know what it is, and there's no other way to find that, which is why they give me this other triangle and that right angle. In this other triangle, this is 89 degrees, this is 44. I can find this angle first. Call it 1 if you want, or just put an X there or a mark. We can find that by doing 180 minus the sum of these two. So first, I need to understand, if I want to call that X, I can, that 180 is equal to X plus 89 plus 44, or those other two angles added together would be 133. Sorry, I was checking my math. 133. And when I subtract 133 from both sides, this unknown angle X here is 47 degrees. Okay, but that's not my answer. Again, I've got to work down to here. Because if this is 47 degrees, these two add up to 90. These two adjacent angles here, if I wanted to call this X, that'd be a bad idea because I already used one variable. All right, but I could just think of this as 90 minus the 47. And 90 minus 47 is 43 degrees. Well, now I have another piece to the puzzle. And if these two together add up to something that would add to 180 to this unknown angle, I can do 180 minus their sum. So I can even write it out like this. I'm going to add those together. Okay, when I add these together, that equals 120. If I do 180 minus 120, I get that my unknown angle is 60 degrees. Okay? Let's move on to one more problem like this. Okay? In this time, it's a little bit different picture, but there are still two triangles to use. One of the triangles, I've given you two angle measures. Another one, I've given you only one, and you have to find the unknown angle. Well, in order to find this one, I need to know this angle. I need to know that one first. What I need you to remember from last unit, sorry, 2 units ago, unit 1B, is that vertical angles are congruent. These are vertical angles. So these two angles have to be the same. So if I can find this one, it'd be the same as this one, and then I can find my unknown angle. Okay, so as I work through this, 21 plus 64 here, 21 plus 64, do the math on the screen for you, it's 85, okay? So, since these two add up to 85 degrees, 180 minus 85 is 95 degrees for this angle. And since this angle is 95, this angle is also 95. And then I can add those two together. 95 plus 24, that's 119 degrees. So this angle that I'm looking for is 180 minus 119, which is 61 degrees. All right, we've got two more quick examples to look at. If you turn the page in your notes again, sorry, one more quick example. And we want to find the values of x, y, and z in this picture, okay? Well, we're going to look at this picture here. We've got 3 different triangles to look at, and there's a unique aspect of each of these triangles that's going to be important for us to recognize. To find the triangle that uses the x, you'll notice there's these markings. This is supposed to tell you that all three sides are the same. You might remember from last lesson, that makes this an equilateral or equiangular triangle. And earlier in this lesson, we already explained that all three angles of an equilateral or equiangular triangle have to be 60 degrees. So these are all 60 degrees. That means the value of x is 60. Now to find these other two, let's look at their individual triangles and see what we can figure out. Let's find the value of y next. Well, this is a right triangle. In this right triangle, one angle is given to us as 60 degrees. This angle is 90 degrees. And so I can find y. But here's another idea I want to present to you. When you look at any right triangles, since one angle of a right triangle is always 90, the other two angles, the two acute angles, have to add up to 90. Here's why. If I subtracted just this 90 from the total 180, 180 minus 90 is 90. So I know these other two angles have to always add to 90 degrees. So to find y, the easy way to do this is just to do 90 minus 60, which is 30 degrees. Okay, so the value of y is 30. Finally, to find the value of z, that's an exterior angle, and these are your two remote interior angles. So again, z must equal them added together. 30 plus 38 is 68. That's how you can find these. Think of these missing angle problems as a puzzle. Find all the pieces you can to see what gets you to what's missing. Okay, we do have a quiz next class after the class where we work on this assignment. So take a look in Canvas for that quiz, and I'll be sending out the access code when it's time for that quiz.